So let's start. What happened? We have Gaussian, we have thesis, Ehsan, eBay, we have TA application, which is something else, but I wanna talk about Gaussian. No. I wanna talk about eBay. Yeah, let's start eBay. There is no difference. In 2 hours we will make it Gaussian. So what do I want about okay, Ehsan sent me an okay, Ehsan read, by the way, he read, we wrote it down, he read, he couldn't show up for a meeting. So still better than nothing. He could read what I wrote and said, actually, it's very interesting. He sent me a paper that is related to that. Look, I wrote what I thought first, and then he said, okay, there is this paper. He didn't say, oh, your approach sucks. He said, okay, there is something similar. If you wanted to look if other people did saying, and then are we allowed to think about it? That's stupid. I want to think about whatever I want. So let's find the paper. Look, by the way, your proposed solution for propensity boosting your notion estimation is very interesting. That is me. For me it is beautiful because it says you can think on your own and come up with an interesting solution. Yeah, why should we read other people's work first? We should first let our brain work and then release it or put it out there, and then people say, okay, there is still solution, and I'm pretty sure that they're not exactly the same solution. It's very interesting. I'm proud of myself. This is for armchair theories. It's very interesting, and it shares interesting parallels with one of the main techniques proposed in the literature. Now we know what is the literature doing, and it's also based on iterative optimization. Interestingly, he didn't tell me what they do. Like what they do in e-commerce. Position bias estimation for unbiased learning to rank. Personal search. Very short paper, by the way. I love that. Okay. We want to read this one. Okay, another paper too. If you give this paper a read before our scheduled meeting, there is also a very similar paper which introduces another form of bias. Addressing trust bias for unbiased learning to rank. This one is 11 pages. Dude, these papers are killing me. 11 pages. We can have papers in 11 pages. I have paper in 44 pages. Like it could be 4 papers. That's why we need to do Gaussian after this to finish that paper. So So let me see. Let's read these two papers. What is the name? Position bias estimation. That's what I need, Ehsan. That Ehsan is so good. Thanks for having Ehsan. He knows about the research area, and he says, okay, this one has done similar to what you did. Then I say, it's so old, we already did that. You need to start with literature review first. Why should I start with my own opinion, my own thoughts first? Oh, literature review. Hate this word. Reading work of some more other stupid people. Alright, this is it. And literature review is for somebody who doesn't know what he wants. If you know something, then do that. Dude, I am so right. I am so fucking right all the time, actually. Now I wanna do. Okay, I also met Munzer yesterday. I wanna update. Actually, Munzer brought a good question that we don't know. What is it? Once we have like the whole notion of whole set ranking and everything, once we have, what do you call it? Once we have a general query, right? Once we have a general query, we don't know what to show to the people, how to decide on what to show to people. Should we show a diverse set of products, or we should maximize, like show only one of those categories that are related to the query? Which I believe that's good, and we need to look at the intention of people, why they search, intention of people, why they are such a general query. Is it because they are lazy and they don't want to type like exactly what they want, or is it because they are just window shopping and they want to see what Nike brought? And then if they're in the window shopping stage, like how can we show them different products that end up in a sale or purchase? However, do you think, okay, that's my question, is that once we are in this, okay, if it is laziness, we have that mechanism design thing about specificity and going through the least trade-off of the cost, cognitive load, everything. If it is about window shopping. What is it? Can we make a window shopping opportunity into a purchase? What should we show them? And then probably for window shopping mode, we want to show them different things. Or are they different? Or does it matter at all? Or does it matter if they're window shopping and they end up, okay, that's the thing. Very good, very good. For a lazy consumer, that's beautiful actually. Guys, wait for it. That's so beautiful actually. For a lazy consumer, what we are saying, oh, consumer has an intent that platform doesn't know. What a beautiful thing. All right. For a lazy consumer, we can say consumer doesn't know what's up. Oh, actually knows what's up, knows what he wants, but he just doesn't have the energy to type in the search bar exactly what he wants, and he types something general, and it then ends up in our mechanism design problem. In the window shopping case, the consumer doesn't know what he wants. He doesn't have an intent. And what platform should give him is giving him an intent. That's so amazing actually. I am gonna write it right now. And then we can study how can we give a person an intent. That's beautiful. Thank you, Monzer. Thanks! Whew! Look, this is my advisor. This is the level of conversation we are having. Like seeds, some thoughts in your brain that will grow up tomorrow. Grow up or will, grow tomorrow. Okay, we have random thoughts, but I wanted to write it down in random thoughts section. Okay, this section, we did our research on it. Well, okay, I want to add the yeah, we can put it somewhere up actually. Yeah, consumer has an intent, but they don't know it. And consumer has an intent and they know it, which is the lazy consumer. They don't know the intent. And we had a conversation on how to give people intent. About advertisement and everything. Alright, of course, I'm gonna pull up my ChatGPT. I wanna say why general queries, not why channel. Reason behind general queries. Purpose of a general query. And I remember we had this paper, Min Min Chen, that she was talking about diversity, so but she didn't say anything about making a person having an intent. Um, why do consumers search why do consumers search general queries? Is it because they are okay, why do consumers search general queries? One can be one reason can be they one can be they find the difficulty of the cost, I don't want to say cost, cognitive load of typing their meaning lazy consumers these consumers know what they want before before Second group are window shoppers. They are window shoppers. They do not have an intent a priori, and they do not have an intent a priori but form one based on the platform suggestion. Mhm. Created intent, observed intent, um, develop intent based on the platform suggestion. After observing the suggestion that catches their interest, truly make a purchase, often in a multitude. All right. So again, let's trust ourselves first. And if I want to model a situation where you build an intent, develop an intent, how does that work? You don't have an intent. Well, what do you have? What do you have that based on that you choose one intent over another? Platform gives you some suggestions. Forget about the rank or list, right? You go window shopping. Uh, if I want to come up with a utility function, and you're taking no action, maybe right now we just don't want to have a utility function thing. Utility function is for like the truthfulness and everything. For the intent shaping study, we may just want to look at the data, see like when people search at a general query, what was their click process, and say, okay, this is how they built it. Mm, this is a menu of options. You can see that. Forget the ranking effect. Um, let's assume the consumer can see through all of the items that platform suggests to them. And it says it is the price for it. Um, give some information. Yeah, I think actually it's quite simpler. You can say he looks at the options, he knows each product, how much produces for him, how much utility generates for him, and how much the cost is. And then they choose the one that maximizes it. Yeah, it's just a simple thing. Okay, now let's assume what happens if we offer a user a flooded list, a user who is in a window shopping mode. Will he buy the same thing? Will he just say, okay, these are my options? What if we assume that they just I don't think actually these two cases are very different now that I think. Oof. At the end, the guy knows how much each product gives them utility. We can have this assumption. Even though they don't know what they want, once they see an object, they know how much utility it generates for them. So, and then how much the price is. So each item, okay, has a value. The difference between this group and the lazy ones is that the lazy ones, if you show them, if their intent is socks and you show them shoes, the utility they generate from shoes is zero, right? But for these people who don't know what their intent is, or they don't have an intent, both shoes and socks have value, and they're thinking which one to choose. Right? So you cannot say if R of shoes is zero and like R of shirt is not zero, R of shoes are not zero as well. And then relevance or utility. And then I want to say what is the utility from each item? Is it the utility exactly that the consumer generates? can I say a window shopper is the same as the lazy consumer? They just did not observe their V. Yeah, let's make this claim. Yeah, I actually like that. Claim how realistic is this assumption? Um, Window shoppers are similar to lazy consumers. They just have not, they just do not observe their utility ex ante. Now, as the platform, which node do you want to show to them? Do you want to show this node and just two category of products, or this higher, upper in the hierarchy node, more categories of products, but we can show less relevance? Well, actually, I always show the first one. I think that's my answer to this question. And you know what is beautiful about this is that you don't know your intent, but if I show you this middle node here and your intent turns out to be not in this section, turns out to be in the lower section, you won't buy anything, platform loses you. So you don't know, platform doesn't know. Or when you search this much, you know that your intent is in this space. And the rest you don't know. Okay, now I want to use O1 now that we thought. Come. Yeah, okay, why did we say that at the beginning? Because at the end, a user knows how much. Okay, I don't like this now because when we say I don't know what my intent is, don't know, we can translate it into probability. I think that's why this is something resonated with me. That okay, the user doesn't know what their intent is. And they're being very honest about how much they know. Sounds pretty good to me, to be honest. It's a good model. Give me how. Because, okay, again, get back to where it started. We cannot assume the consumer doesn't know anything. Once you show a product, you should be able to say, okay, potatoes are worth like this much to me. Tomatoes are worth this much to me. I don't know what fruit to buy, but I know when I'm getting a potato, it's this much. Unless you say that I don't know how much potato is worth for me before I eat a tomato and say, okay, that is its worth. I have to try it first, then find out what it is. So you're saying I don't have a utility formed yet. Like I haven't had potatoes in my life at all so far, and I want to have a potato. I don't know how good the potato is. I want to try it. I haven't tried tomato as well. So what it is, it says that I don't know my utility function. Which is true. Which is not very difficult actually. My previous works also, utility of you um, depends on a random variable outside your control and all. So in a sense, you don't know what your utility will be. Just randomness, extra randomness makes you don't know what your utility is. Um, maybe you as a platform can give me a hint how. But you did not upload. I think it gets very similar to what Nadine said. Well, there should be a function, there should be a utility function, just the user doesn't know it, you know? Otherwise, we cannot say, okay, we tried, like, what happened? Let's assume you tried potato. You got 300 as utility. Well, you didn't know, but now you know. It's kind of like reinforcement learning, multi-arm bandit shit. Even in those cases, we have a utility function, but yeah, let's take a look at that. You have a utility, but you don't know it. So let's not use O1. Always good. What is multi-arm bandits problem? Economics. Decision making commonly used in machine learning and economics. This is named from slot machines, often referred to as one-armed bandit. Slot machines or arms, each offering different but unknown payouts. That's exactly the case. Like different slot machines are like one is potato, one is tomato, and we don't know what is their payout is. You are in a casino with multiple slot machines, each offering different but unknown payouts. The challenge is to decide which machine to play, in what order, and how many times to maximize your total reward. Well, if you wanna look at the e-commerce, when somebody's window shopping, they're not gonna buy the product and try. If they bought every product once, that would be amazing for the platform to have everybody in a window shopper. But what they receive is just a signal of how good that product is. Exploration, exploitation. Their payout rates. Online advertising, which ads to show. Oh, okay, that's for the platform. We are talking about is our user if user is in exploring mode, is like a agent solving multi-arm bandit. Clinical trials, choosing between two. Recommenders. These are all like test and trial of the platform. We want to see platform knows what's up, user doesn't know what's up. Perfect. I think, by the way, they are curating their answers to the history of what we searched previously. Okay. But what about these RTs? Do we have the function RT of AT? Which are known, which are not known? Mhm. Each arm has an unknown reward distribution. So we don't know the reward exactly, but we know the distribution with mean mu A. Arm A is pulled at time step t. Reward RT is 8 samples from the okay. Okay, that's good. Is that the means mu A are unknown to the agent. Mu A is also unknown. Okay. What does agent know? Between exploring less known arms to estimate them. Mm-hmm. So each of these items have a relevant, like so for a lazy consumer, we knew the RIs. Assume we know because we have this boosting effect and relevance, but let's assume we know the RIs and another thing is that Yes. So that distribution, the relevance, platform knows more about that distribution because platform has a lot of knowledge about so many consumers who bought those different items. So platform's task is just to give them information that okay, this item has this much value. Okay, that's terrible. I don't want you to make so much change. You're removing the reasoning behind. Not utility, but their intent. So in the first one, we are saying they don't know their intent ex ante. In the second one, we are saying that they don't know their utility. Exploit. Doesn't mean, okay, I clicked on a product once, I'm done with it. So those R's are random. Well, now it's very similar to the data market thing. What was in data market? Data market platform knew the environment and the utility dependent on the environment. And how it forms. Okay, that's not also crazy with more knowledge. Sounds really good. I think, yeah, that's pretty good actually. So, an exploring consumer, to summarize, exploring consumer, either they don't know the intent, okay, what we said actually here is two forms of modeling for exploring consumer. One is that they don't know their intent. Second one is that they don't know the utility that it generates. Each item generates. To summarize, window shoppers can be modeled through two approaches. And then we can study which model works better. 15 intent, or they do not know how much an item is valuable. Do you write valuable like that? That was really good. I'm happy I wrote it down. Perfect. And then I wanna say let's take a look at Essence paper. Do you have anything here extra? So this is stuff I wrote down, all of them. And interesting can be like comparing the solution from the two approaches and see how similar, what are the common intuitions. All right, I think, okay. Understand. Okay, I think now I just made myself empty. Everything that was inside is gone. Feels really good. I'm ready to listen to the word. And so for that, I wrote down everything I wanted. We can go further on any of them, but now it's the time to listen what the other paper is saying, and then we can have extra. This is just like a conversation, Not this. Where is the paper? Okay. Oh, okay. Position bias. Why are they here? Trust bias. Is it the 9 page? Yeah, and we always start with the shorter one. That's our rule. Nadav Golbandi. Where is she from? Or where is he from? All right, I need to speak louder. I feel I need to. Oh, they're all Google. I love that. I love people in Google. That's amazing. And thanks for being in Google. Thanks for. They are Google again. Again, Google. Google. Fucking people from Amazon, you are lazy as bitches. Okay, that's really good. I like to read these papers.
Hey, Speechify here. You have exceeded your daily HD word limit. In order to continue enjoying your experience with high quality voices, please upgrade your subscription by clicking the upgrade button. If you are not ready to upgrade, you can continue listening with non-HD voices.
What does HD stand for? High definition? High definition, alright. Now, because we have our method of doing RIB pi, I'm sure it's easier for us to go through these papers too. Dude, I learned it. I learned how to do research. It may be a bit late, but finally I learned it. I learned to do the research the way I like. That's it. Which one was the shorter one? Position bias is the short term.
Technical presentation WSDM 18, February 5th to 9th, 2018, Marina del Rey CA, USA. Position bias estimation for unbiased learning to rank in personal search. Suan Hui Wan, Abstract 1 Introduction.
Oh, that's
A well-known challenge in learning. A well-known challenge in learning from click data is its inherent and bias, and most notably position bias. Traditional click models aim to extract the query, document relevance, and the estimated bias is usually discarded after relevance is extracted. In contrast, the most recent work on unbiased learning to rank can effectively leverage the bias and thus focuses on estimating bias rather than relevance. 2031. Existing approaches use search result randomization over a small percentage of production traffic to estimate the position bias. This is not desired because result randomization can negatively impact users' search experience. In this POD-4, we compare different schemes for result randomization, i.e., RAND top N and RAND pair, and show their negative effect in personal search. Then we study how to infer such bias from regular click data without relying on randomization. We propose a regression.
He refined this. Fuck off, dude.
Here's the passage repeated at a well-known challenge in learning from click data is its inherent bias, most notably position bias. Traditional click models aim to extract the query, document relevance, and the estimated bias is usually discarded after relevance is extracted. In contrast, the most recent work on unbiased learning to rank can effectively leverage the bias and thus focuses on estimating bias rather than relevance. 2031. Existing approaches use search result randomization over a small percentage of production traffic to estimate the position bias. This is not desired because result randomization can negatively impact users' search experience.
Yeah, that's true.
In this paper,
we don't want to give the users a bad experience so that we can, we don't want to do it in very big numbers. Maybe, yeah, one user, okay, then I don't know what the number is, but we don't want to give all the consumers a bad experience just to find out what those RIs are.
Schemes for result randomization, i.e. RAND top N and RAND pair, and show their negative effect in personal search. Then we study how to infer such bias from regular click data without relying on randomization. We propose a regression-based expectation maximization algorithm that is based on a position bias click model and that
like we find R first, then assume B R first, based on R compute B, then take this B as granted, then find R, B, R, B, R, B, R, B.
Highly sparse clicks in personal search.
And this is really good. If this paper is doing it for us and gives us those position biases and the relevance separated, that's amazing. I didn't want to do a research on that. This is amazing. We do this and it gives us the solution. Now we have our IMBI. Perfect.
And maximization, algorithm that is based on a position bias click model and that can handle highly sparse clicks in personal search.
Oh, sparse.
We evaluate our M algorithm and the extracted bias in the learning to rank setting. Our results show that it is promising to extract position bias from regular clicks without result randomization. The extracted bias can improve the learning to rank algorithm significantly. In addition, we compare the pointwise and pairwise learning to rank models. Our
Compare
results show
pointwise-
that pairwise models are more effective in leveraging the estimated bias.
Perfect, beautiful. I like this paper. And this is the answer to our solution. Actually, I am happy that this paper has done it because it was not the thing we wanted. We want to study the whole set ranking, but I wanted to get a better understanding of how these work. Maximization.
Here's the passage repeated as personal search is an important research topic in information retrieval that has been evolving from desktop search 13 to on-device search 21 and more recently to email search 5. With the increasing popularity of cloud-based email and storage services, there is a large amount of personal data stored in the cloud. This large amount of data calls for effective search capabilities to improve its utility to 5, 6, 15. The important difference of personal search from web search is the private content in personal search. Users can only see and search their own content. This presents an important challenge when applying learning to rank techniques, because collecting explicit relevance judgments becomes much harder and raters can only label their own documents with their own queries. Though possible, such an approach can be heavily biased by the selected raters and costly to maintain due to the fast evolving nature of private content.
By the way, let's take a look at these people. Who are they? Maybe we can connect to them. Jesus, bruh. Yeah, let's email them. Why not? Let's email them and say, I read your paper on this. Interested. Let's do some research. I sent it for the Airbnb paper. Did I feel I'm hunching? My legs. This, Jesus, they are all the G's. They're all the G's. That's great. Now that we have these papers, we know the people. Papers and people are related. Wow, he's Google DeepMind. And yeah, let's email these motherfuckers. Homepage. Well, how can we connect with you? Oh, they have their email on the. Yeah. Oh. Jeez. All right. Oh, they don't have it. Oh, they have it. All right. They are all Google DeepMind people. Oh, okay. By the way, here. They are all on large language models. Oh, that's good. That's related. Generative information retrieval. Dude, they are good people. Let's email them. Let's see what's up. Bro, they are real researchers. That's related to one of Ehsan's paper. Mm. Tweet recommendation. Perfect. I want to email them. All right. Let me pause. Let me pause. That was a long break. So many things happened. Most important thing, I'm back. And I want to read this paper, finish it with you.
Here's the passage repeated as Click data in personal search provides implicit but abundant user feedback. It thus becomes a natural source to improve personal search quality. However, a well-known challenge in learning from click data is its inherent bias, position bias 19, presentation bias 32.